Hi all, this is going to be the first video of a series on Contingencies 1. I have decided to upload YouTube videos for this module as there's a lack of resources online. Furthermore, I attained 92% in Contingencies 1 when I completed this module last year as part of my actuarial science degree. This demonstrates that I have the pertinent knowledge to teach this module and empower the next generation of students. What is Contingencies 1? In essence, Contingencies 1 is an actuarial science module that utilizes data from life tables to compute the present value of different insurance policies. That's sort of an oversimplified definition, and you probably don't understand what any of these terms mean. So in this video, we'll begin by trying to focus on one of the key elements within Contingencies 1, which are the life tables, and we'll try to use timelines to understand what LX is and try to construct a life table using these LX values. We'll then move on to trying to understand what DX, QX, PX, T vertical line S, QX is, and how to calculate these terms. So, as I said, for the first part of this video, we're going to be using information from these three timelines, let me just zoom out a bit, to construct our life table here. And just to provide a quick point of clarification, a timeline is just a visual representation of an individual's lifespan from birth to death. And you can see on the top right hand side as well that the notation here, where a green star indicates that an individual was born and a red star indicates that an individual died. So for example, with individual 1 was born on the 5th of April 1990 and died on the 6th of May 1991, which means that they lived for 1 year, 1 month and 1 day. I've also constructed a timeline for individual 2 and individual 3, and I'm sure you can tell, but I've made up these dates. They aren't based on any data, again, you can probably tell as the average person lives much longer than these individuals. So the first thing that we're going to try and calculate is LX. And you can see the definition highlighted in yellow, and you'll see as well throughout this video that I've highlighted all the formulas that you need to know for this topic in green. So LX is just the number. The hashtag just means a number or a count. The number of individuals alive at age X. So L0, for example, would be the number of individuals alive at age 0. L1, the number of individuals alive at age 1, L20, the number of individuals who are alive at age 20, and so on. Now, you can see with this example one here that this person was born on the 1st of January 2000 and died on the 2nd of January 2001, which means they lived for 1 year and 1 day. Now, this person, of course, was born, so they would be included in this L0 count, but this person would also be included in this L1 count. Even though they died 1 day after their first birthday, they were still alive during their first birthday, therefore they would be included in this L1 count. So the reason I say this is because this is sort of the definition that you'll find in perhaps textbooks and your teachers will tell you, but a better way of trying to understand what LX is LX would be the number of individuals who are alive during their Xth birthday. So for example, L1, the number of individuals who are alive during their first birthday, L20, the number of individuals who are alive during their 20th birthday, and so on. So I'm going to rub this out because this has got nothing to do with the timeline, the life table that we're going to try and construct. But this was just used as a point to, this example was used to simply illustrate that a better way of trying to understand what LX is the number of individuals who are alive during their Xth birthday. So we're now going to try and fill in these values here in this life table using data from these three timelines. So what is L0? L0 here would be the number of individuals who are alive during their 0th birthday, i.e. who were born, and you can tell from the data that all three of these individuals were born. L1, the number of individuals who are alive during their first birthday, this would be 3, all 3 individuals were alive during their first birthday. L2 would be 2, why? Because individual 1 wasn't alive during their 2nd birthday. They died before they turned 2, therefore they wouldn't be included in this L2 count. However, individual 2 and individual 3 would be. L3 would be 1. Why? Well, individual 1 and individual 2 weren't alive during the 3rd birthday, but individual 3 was. And finally, L4 would be 0. Why? None of the individuals were alive during their 4th birthday. So I hope this has given you a better understanding of what LX is, and we're now going to be moving on to trying to understand what DX is and how to calculate this term. For DX, we're going to look at data from page 68 of the IFOA Orange Book, and this book looks like this. And if you're doing this module, of course, double check with your teacher, but I'd highly recommend that you purchase this book, as you will use this book frequently, and it's kind of a common book that's used not only in this module but in other modules as well. So I'd highly recommend that you get this book, and I'll include a link to it in the description. So as you can see, what you'll see as well throughout this video is all the actuarial terms I've highlighted in yellow, and then the formulas I've highlighted in green, and I've done a summary page at the end as well. So what is DX? Well, DX is just a count of the number of individuals that die between age X and X plus 1. A better way to, how do we calculate DX? Well, let's just go through a random example. So say if you go to a hospital and you notice that there are 10 individuals who are in eternal comas, and then after a year, of those 10 individuals, 9 are alive. How many died? Well, this information, it doesn't tell us how many have died, but we can deduce from these two counts how many people died, right? Because somebody is either alive or dead. So the number of people that died would be 1, because the difference in the counts. And that is essentially what DX is. DX is just trying to find the number of individuals that die between, for example, D0 would be the number of individuals that die between age 0 and 1. And the way that we calculate that is using this formula, DX equals LX minus LX plus 1. And this formula, again, just like the hospital example, we're just trying to find the difference in the counts. So again, with DX, D2 would be the number of individuals that die between age 2 and 3. D20 would be the number of individuals that die between 20 and 21, and so on. So with D0, again, just like the hospital example where we did the 10 minus 9, we're just trying to find the difference in the two counts. So if we apply the value of X equals 0 to this formula, we get D0 equals L0 minus L0 plus 1, and L0 plus 1 is just L1. So D0 is L0 minus L1, which is 100,000 minus 99,186. And I recommend here that you pause the video and see if you can try and calculate what D1 and D2 is. So again, I'm going to go over how we do this now. So again, if you D1, we're just trying to find the difference. D1 is just the difference in the count. So it's L1 minus L2, which is 99,186 minus 99,124, which is 62. And finally, D2, again, is just going to be the difference in the counts. So D2 would be L2 minus L3, which is 99,124 minus 99,086, which is just 38. So these are the answers I got, and let's just double check the live table to see that they're right. Yes, so all these values are correct, and you can also as well try and see if you can calculate what D3 and D4 is, and you know that your calculation is right if the values you get match up to these tables, match the values in the live table. And just a quick point as well is that when I say a live table, you kind of see a live table like this, where you have all this different information, And we have Lx, we're now going for dx, but we're also going to go through qx, and then mux and ex will go through on a different video. Live table, essentially just a table with all of this information. And you'll see why we use this in one of the later videos. I hope that's given you a better understanding of what dx is and how to calculate it. And we're now going to move on to qx. TQX is the probability that a life-aged X dies within 2 years. So for example, 1Q0 would be here, which is the probability that a life-aged 0 dies within 1 year. 3Q1 would be the probability that a life-aged 1 dies within 3 years. I'll just quickly draw a timeline to illustrate how 3Q1 would work. So again, the probability that a 1-year-old dies before they turn 4. Why 4? Well, 3 years from 1 would be 4. So when we're referring to 3Q1, we're referring to this red probability here. Again, which is the probability that a 1-year-old dies within 3 years, i.e. they die before they reach the age of 4. And one quick thing to note with TQX is that if there's no value of t, then t is 1. So for example, if we have Q4, there's no t value, therefore t is 1. If we have Q0, there's no t value, so t is 1, and so on. So if we had, for example, say Q78, there's no t value, therefore t is 1. And this works for this is the case when there is no t value. Now, how do we calculate TQX? Well, let's refer back to the hospital example. So let's just say again that we had, let me just draw this a bit better. In the hospital example, we had individuals who were 70 and 71, and there were 10 individuals alive at age 70, and then after 1 year, of those 10, only 9 survived. Right, we have 10 individuals after 1 year, 9 survived. And then remember from the previous section, we said that we can deduce from the difference in the count that 1 individual must have died. And again, this was doing 10 minus 9. And essentially what TQX is trying to find the probability of this happening. And it should be quite straightforward because we have 10 individuals and 1 of them died. Therefore, the probability that a life age 70, using these numbers, died before they turned 71 would be 1 over 10. And if you look at the formula in green, so for QX, remember QX is the same, the value of t is 1. So QX is the same as 1QX. So QX is just finding the difference. This is just doing the difference in the count, which was Lx minus Lx plus 1. And in the hospital example, Lx was 10 and Lx plus 1 was 9. So that's 10 minus 9. And then Lx is just the original count, right? Because the denominator is just saying the number of individuals exposed to the risk, because 10 of those individuals could have died, but only 1 died, so therefore the probability of death would be 1 over 10. So now I'm going to go through a few examples so that you can better understand how to calculate TQX. So if you pause the video, and we'll now go through some of the examples. Sorry, I meant the questions. So Q0 is, again, there's no t value, so t is 1. Q0 is the same as 1Q0, and again, we just do the difference in the count. And again, for these questions, we're going to be using the live table here. So Q0 is the same as 1Q0, which is L0 minus L1 over L0, which is 100,000 minus 99,186 over 100,000. And that is 0.00814. Now, just quickly, how did I do that? Well, we had, if I just go move it down a bit here. So I'm sure that you probably understand how this works anyway, but I'll just go very quickly again. So we had L0 was 100,000, L1 was 99,186. And these are people, here is age 0 and here is age 1. So we just calculated the number of people that died here, i.e. between 0 and 1, which was 814. And then we said, well, the probability of this happening, because we have 100,000 people and 814 of them died, the probability of this happening would be 814 over 100,000, which is 0.00814. And what you should notice as well is that when we do this L0 minus L1, L0 minus L1, of course, is D0. If you look at this part here, it's dx over lx, when we have t is 1. So now see if you can do what Q1 is. So again, there's no t value, so t is 1. So Q1 is the same as a 1Q1. And again, we just do the difference in the counts. It's L1 minus L2 over L1, which is 99,186 minus 99,124, which is over 99,186. This equals 62 over 99,186, and you should get 0.0063. Now, if you notice in these, if I rub these values out, and again, you can check that you've done these questions correctly by checking the values on the live table. And you can also as well try, we've only done Q0 and Q1, see if you can do as well Q2, Q3, and maybe Q4, just so you have a better understanding of how to calculate these values. And what you notice here as well is that the final decimal place is off, because we had 0.000625, and of course rounded to 5 decimal places, this would be 0.0063. Sometimes mistakes like this, they don't sometimes round the values in the live table correctly, so I wouldn't worry about it too much. As long as you get a value that's incredibly similar to that on the live tables, then don't worry about it. So see if you can calculate what 2Q1 is. Pause the video and I'll be going over the answer. So I'm just going to draw the timeline out. So 2Q1. So we have individuals age 0, 1, 2, 3. And L1 is 99,186. And then L3 is 99,086. And we're trying to find the 2Q1 again, is the probability that a live age 1 dies within 2 years. If a live age 1 dies within 2 years, it means they've died before they turned 3. So we're trying to find this red probability here. So first we need to find the number of individuals that died. And this would be L1 minus L3 over the original count. So L1 minus L3 is just finding the number of individuals that died. So in this case, it would be 100. And we're just dividing this by the total number of outcomes over 99,186. So what we're saying is that 100 people died. So we had 99,186 individuals. And of those 99,186 individuals, 100 of them died. Therefore, the probability of death would just be 100 over 99,186. Again, this value here we got by doing the difference in the count, and this here is the total number of outcomes, right? Because all 99,186 individuals could have died, however, only 100 of them did. Therefore, the probability of this happening would be 100 over 99,186. And you should get this to be 0.000814. 0, 0, 1, 0, 1 to 5 decimal places. So I hope that's given you a better understanding of how to calculate TX, and we're now going to move on to TPX. TPX is the probability that a life age X survives for at least t years. For example, 1p0 would be the probability that a life age 0 survives for at least 1 year, or 3p4 would be the probability that a 4-year-old survives for at least 3 years, i.e. till they turn 7, because 7 is 3 years after 4. One quick thing to note as well, I put it in this bubble here, but just like we had with TQX, if there's no t value, then t is 1. For example, with P2, there's no t value, therefore t is 1. Or with, say, P0, there's no t value, therefore t is 1. How do we calculate TPX? Well, let's refer back to the hospital example, where I'll just add in age from here. So if I put age here, 70, 71, 72, I'll go up to 73. And remember, we had 10 individuals who were alive at age 70, and of those 10, after 1 year, only 9 of them were alive. And let's just say after a further 2 years, only 6 of them were alive. And we said that, previously we said that Q71 was just 1 over 10. And we got this 1 from doing the difference in the counts. And this 10 was the total number of possible outcomes. Right, because all 10 of those individuals could have died, but only 1 did. So TPX in this case is trying to find the probability of survival. So what's the probability that a 70-year-old survives for at least 1 year? Well, it's quite simple. We have 10 individuals, and of those 10, 9 of them survived after 1 year. There were 9 alive. And the probability of this happening is just 9 over 10. Why? Well, 9 is the total number of successful outcomes, in this case being alive, which is 9, and then 10 is the sum of all the possible outcomes, right? Because all 10 of these individuals could have been alive, but only 9 were, so the probability is just 9 over 10. So that's what 1p70 would be. It'd be 9 over 10. What would 3p70 be? It should be quite simple. It's 6 over 10. Why 6? Well, 3p70 is referring to the probability that a 70-year-old survives for at least 3 years. So we take the count at this point and then we divide it by the count at this point. And if you look at the formulas, this formula here comes from, we've got it over here, and then this formula here from this part. One other thing you should notice as well is that if you sum the probability of death and probability of an individual surviving, provided that the t values and x values are the same, then it should be equal to 1. Why? Well, there's only 2 possible outcomes in this model. Either an individual dies or an individual survives. So when we sum if we sum all the probabilities of every outcome, then it should be equal to 1. Just like if we have a coin, if there's only 2 possibilities with a coin, you either flip a heads or flip a tails. And if you sum the probability of those 2 outcomes, you get 1. The similar logic applies here. We're now going to be going over some questions. So see if you can calculate these values here. using data from this life table. So pause the video. But I'm now going to be going over how to calculate them. P0, again, there's no t value, so t is 1. And the way that we find this is just doing the count after 1 year. So the count here, which is L1, over the count at age 0. So L1 over L0, which is 99,186 over 100,000, which is 0.99186. We'll call that method 1. Method 2 is using this formula. So I don't think I've really gone over this, but again, I have actually. When you sum the probabilities of all the outcomes, you should get 1, and that's where this formula essentially comes from. Method 2 is saying that P0 is the same as 1 minus Q0, which is 1 minus, and we have Q0 here and these values here, 0.00814, and this is 0.99186. P1, how do we calculate P1? Well, there's no t value, therefore t is 1, it's 1P1. We just do the count after 2 years over the count of the number of individuals alive at age 1. L2 is 99,124 over 99,186. And that is equal to 0.99937. That's method 1. Method 2 is doing 1 minus, so P2 is P1 is 1 minus Q1, which is 1 minus 0.00062, which is 0.99938. You'll notice that these two answers are different, but again, this is due to the rounding error that I mentioned previously, so I won't worry about it too much. 2P1 is simply L3 over L1. I'll just go over it quickly actually. So if I draw the timeline out, we have age, say 0, 1, 2, 3. And we're trying to find the probability that individuals at this point here survive to this point here. So all we do is we do the count at this point over this. So L3 is 99,086. L1 is 99,186.99899 to 5 decimal places. Method 2, we don't have so 2P1 is 1 minus 2Q1. We don't have this value, but we did calculate it previously, and we got it here, 0.00101. 1 minus 0.00101, which is 0.9989. And there we go. So I hope that's given you a better understanding of TPX and how to calculate it. We're now going to move on to try and understand what T vertical line SQX is and how to calculate this term. T vertical line SQX is the probability a life-aged X survives for T years and dies within S years. For example, 3 vertical line to Q1 is the probability a life age 1 survives for 3 years and dies within 2 years. So it would be a life age 1 survives for 3 years and then dies within 2 years. And one thing to note as well when we talk about T vertical line SQX is if there's no S value, then assume that S is 1. So for example, if we have T, I'll do it in black. If we have T vertical line Q40, then that's the same as when S is 1. Or if we have, say, 2Q44, again, when there's no S value, S is 1. Very similar to TQX and TPX, but this time it's with an S. How do we calculate T vertical line SQX? I've done an example here below using hospital data, just a random example I made up. And what we said was we had 10 individuals alive at age 70. After 1 year, 9 of those 10 individuals were alive. And after a further 2 years, 7 of those individuals were alive. So the question is, what is the probability that a life age 70 survives for 1 year and dies within 2 years? The key thing here when we do these questions is we need to split this statement in two. So we had the probability a life age 70 survives for 1 year and dies within 2 years. If I add the green colour here, so they survive to this point and then they die within this point, between 71 and 73. So the probability a life age 70 survives for 1 year is just 1p70. The probability a life age 71 dies between 71 and 73 is just 2q71. Therefore, 1 vertical line 2q70 is 1p70 multiplied by 2q71. Why do we multiply them? Well, in order for this event to happen, the individual must first survive to age 71. A 70-year-old can't die between 71 and 73 unless they have turned 71. Just like a 20-year-old can't die between 25 and 26 unless they first survive to 25. So that's why we multiply the two probabilities together. And the reason we multiply them is because the two probabilities are independent of each other. Just like, say, for example, throwing a dice and throwing a coin, you would multiply those two probabilities together because the outcome of one doesn't affect the other. If we go back to here, we have 1p70 times 2q71, and 1p70, if you recall, is L71 over L70, and then 2q71, all we do is we find the deaths here by subtracting L71 minus L73 over L71. And doing some basic algebra manipulation, you should notice that these two values cancel out, and we're left with L71 minus L73 over L70. And in this case, L71 minus L73 would be 9 minus 7 over 10, which is 2 over 10. And that kind of makes sense just by looking at it without doing any calculations. We see that there's 10 individuals, and we know that the 2 individuals die between 71 and 73. Therefore, the probability that a life age 70 dies between 71 and 73 is 2 over 10. So the logic for this formula here, if I put it in orange, is simply subtracting the difference in the counts. So in our example, we did L71 minus L73 over L70. And again, we showed this by, you can see from the algebra, that basic algebra manipulation, that we had some cancelling out. So see if you can do this probability. Again, there's no, I'm not gonna just do the calculation. You don't have to substitute the numbers in, just try and do the calculation. So Q 0 1 3. So pause the video and see if you can do it. So 1 vertical line 3 Q0. Again, it's the probability a life age 0 survives for 1 year and then dies within 3 years, i.e. they die between 1 and 4. And again, we can split this up into two different parts. We have 1P0, which is this part here, and then this red part is 3Q1. We multiply these two together because they're independent. 1P0 again is L1 over L0, and then 3Q1 is L1 minus L4 over L1. These two cancel out, and we're left with L1 minus L4 over L0. Finally, this is a takeaway question to see if you can do it by yourself. But using the logic that we just gone over, see if you can prove that 0 vertical line 3 Q70 is equal to this. And I've given you a hint. Try and use this method where you try and add all of these probabilities up. You can also as well try and just do it the way that we've done it above as well. So I hope that's given you a better understanding of what T vertical line SQX is and how to calculate this term. To conclude, I have just done a summary slide showing all the actuarial notation and formulas that we have been through in this video. Thank you all for watching. If you enjoyed this video, please make sure to hit the like button and subscribe. For those seeking a more personalized learning experience, I offer private lessons. Feel free to connect with me on my Instagram page that I've linked below in the description. Once again, thank you for watching, and hopefully I'll see you in the next video.